Hello everybody, welcome back to the CCNA routing switching video series brought to you by ABY Design and Tech. In this video, we are going to have a look at the function of a server and the role it performs in today's computer networks. So to begin with, the first question you guys are probably asking yourselves is, Abda, what is a server? I've heard of this terminology before, but I've never had an accurate or basic description of what a server is, and let alone what it actually does. Well, simply put, a server is just a computer system that provides a service to another computer, hence the name server. So I know what you're thinking, Abda. Does that mean that I could take my old computer and use that as a server? And the answer is yes. You could literally take an old computer, set up something like a file server on it. So you could turn your old computer into a file server, then you could have the other computers in your home network use that centralized computer to store files, to retrieve files, and to save files. Now, does that mean that at an enterprise we could take an old computer and use that as a server? Now you could, but it's probably not going to be a good idea. Servers usually are going to be specialized computer systems that have a whole ton of hardware resources. So we're talking about a whole load of RAM, a whole load of CPU, a massive hard drive, very fast Ethernet speeds. The reason being is because we are going to have a lot of computers trying to connect to that server in order to request its resources. So as an example, if it was a file server, we would have a lot of computers in an enterprise network, could be 500, 1,000 computers, constantly speaking with that server, constantly trying to retrieve files from the server, upload files to that server, maybe transmit files from one file server to another file server, etc. So that would be the reason why we wouldn't use an old computer as a server in an enterprise environment. But a server, at a very base level, all it is just a computer that provides a service to another computer system. And like I said before, normally it's a very powerful computer system that is dedicated to providing services to other network devices. And that's the main difference between a server and a normal computer. Normal computer, like a laptop, etc., which is not set up as a server, would allow us to interact with the network. A server is on 24/7 and allows us to essentially obtain a service, or offers a service to us. So if you think about it, we use our laptops to browse on the internet. When we actually visit a web page or a website, we are actually communicating with a web server, and that web server is offering us a web service. It's saying to us that you can communicate with me, you can connect with me to obtain a web page. So us as the users, we're using our computer, we're using our laptop to communicate with this web server to obtain this web page so that we can browse on the internet. So like I said before, servers have normally more powerful hardware than a normal computer. Like I said before, this is because it's going to be processing requests from multiple clients. Now, what's a client? All a client is just a computer system, or a computer, so tablet, laptop, mobile phone, desktop PC, etc., that is requesting a service from a server. As an example, we could have a computer which is requesting a web page from a web server. Now, servers also run specific software that offers features not available on your normal Windows 10. As an example, Windows Server 2019 or Windows Server 2012. Now, those operating systems, first of all, they allow the computer, or those operating systems inherently can process more requests from client computers than, let's say, your normal Windows 10 or your normal Windows 7. Secondly, those operating systems also offer more services than your normal Windows 10. As an example, we can activate web services, we can activate file services, we can activate NTP services by the click of a button on the Windows Server operating system, or on operating system specialized for server infrastructure. On your normal Windows 10, you probably won't have the functionality without having to install additional software. So now let's talk about the different types of servers. So as an example, there are many more servers than this, but these are just some basic types. We have a web server. So a web server, it just stores a website and allows a client to access a website. Email server, it stores emails and allows clients to access the email. File server allows a client to store and retrieve files. Now, these are some of the different types of servers, but it's important to know that we can run these servers on any computer system that we want. like I said before, the reason why we choose powerful computer systems is because they've got the ability to handle multiple clients, multiple computers talking to them at the same time. Now, in our home environment, where we've got, let's say, 4 or 5 computers, we're not going to need to have a £3,000 or £4,000 server. We could literally just buy a £300 to £400 PC and set that up as a server. We can even set it up as a media server where we can retrieve, let's say, photos. We can save photos on that computer. We can save films on the computer, and we can stream films from that computer so that we can watch them on our TVs, etc. But like I said before, these servers, usually in the enterprise environment, like let's say Netflix, or let's say an enterprise company, you're going to invest in a lot of powerful hardware just so that you can handle the number of requests that are going to be put through every day. Now, we could actually have an individual server for each server. So we could have an individual computer operating as a web server, individual computer operating as an email server, individual computer operating as a file server, or we could have all the services running on a single device. So let's have a look at this. So let's look at the base function of a server. So in this case, let's take this web server. Now, server can either be on your local network, like I said before. I could actually have or set up a computer as a web server on my home network, so I can then retrieve a website from that web server. Now, chances are, if it's set up on my home network, I'll only be able to retrieve stuff that I actually put on that server. Or a server can be reachable out on the internet. You can think of this as the different websites you access. So websites you access like gold.com, YouTube, so that you can watch these amazing videos, google.com. Those websites are all going to be stored on web servers which are reachable out on the internet. So in this case, this PC wants to view youtube.com because let's say this is Bob on this PC. He's heard about ABY, Design and Text, amazing YouTube videos. He wants to go and watch it. So he's like, please send me youtube.com. This request is sent all the way over to the web server out over the internet. The web server receives this request and he's like, okay, I know that Bob wants to view youtube.com, so now I'm going to send that web page over to him. The home page, the first page that you see when you access youtube.com, I'm going to send that over to Bob as requested. And also, it's important to realize that as this PC is communicating with his web server, he actually establishes, so we will go into depth later on in this series, but he will actually establish a connection with that web server, and that connection will be active as long as that PC is communicating with the web server. So as an example, you visit youtube.com, that connection you are going to have with the YouTube server is going to be active whilst you're on youtube.com. So you request one web page, okay? Then you want to, let's say, view a video. You request another web page, etc. So whilst you're on youtube.com, that connection between yourself and youtube.com server is going to be active. As soon as you exit that website, the connection is going to die. Physical or virtual? Very important question. So it's important to note that in years gone by, so we're talking about decades ago, normally the servers would have been individual computer devices. So they would have been some sort of physical hardware. Now, the problem with that is that if we wanted to upgrade that server, then we would have to power down that server. We would have to have an outage window, and then we would have to actually fit or install stronger hardware components, so more RAM, better CPU, in order to improve the performance of that server. However, nowadays servers can actually be virtual appliances running in a virtual environment known as VMware. Basically, what VMware allows us to do, it allows us to install the, let's say, the VMware operating system or the hypervisor or wherever on a single physical appliance. So we can essentially have an extremely powerful computer with a whole load of CPU, a whole load of RAM, a whole load of hard drive space. And we can install this VMware operating system on that computer system. Then we can take those resources, we can generate virtual servers, and then we can share the resources out between those servers. Now, this can be a bit confusing, so you'll see in a few minutes. I'll demonstrate this with a picture because it makes it easier from a conceptual point of view to understand. Now, it's important to know that servers can also be in the cloud. So now I'm thinking about AWS, I'm thinking about Azure, where we can actually have our server resources, or we can actually have our servers out on the cloud. Now, the benefit is that we can use the cloud to have our servers on there so that we can essentially use the almost infinite resources of the cloud. So essentially what we are doing is that we're paying a cloud service like Microsoft, Google, etc., Amazon, to essentially host our servers out on their cloud infrastructure, out on the infrastructure. Now, the reason why we're going to be doing this is because it makes it so much easier to spin up servers. It also makes it so much easier to add more and more resources onto our servers. So we can literally just pay a bit more extra. We could, let's say, put more RAM, more CPU onto our virtual servers. That's one of the main benefits of having our servers on the cloud. Now, one of the drawbacks is that obviously, because it's all out on the cloud, it means it's not on our network. If we lose our internet circuit, it goes down, then we are kind of screwed. However, that's why we invest in things like high-speed internet circuits and also redundant internet circuits as well. So let's have a look at how we can virtualize these servers. So in this case, we have a web server, an email server, and a file server. Now, in years gone by, these would have been physical devices, which means that we would have had to pay, let's say, $3,000 for this web server, $2,000 for this email server, $5,000 for this file server. These would be physical devices taking up physical space in our cabinets, in our racks. Now, what does that mean? If we wanted to, let's say, upgrade the email server, the web server, or the file server, we would have to have some downtime. We would then have to go through the process of, removing, let's say, the cover from these servers, installing new RAM, installing new CPU, etc. And then obviously testing to make sure that everything's working after it's powered back up and that there's no errors. Now, with virtualization, essentially what we do is that we take those physical servers and then we spin up virtual servers onto a single system. So in this case, we'll have a physical appliance, let's say, with a whole ton of RAM, a whole ton of CPU, multiple NIC cards, or multiple network interface cards, etc. Just a whole lot of hardware resources. And then we spin up this virtual server, this server which exists on this appliance, and then we assign that virtual server some resources. So we'll assign it some CPU, some RAM, some hard drive space, etc. We would assign it a network interface card so it can communicate with the outside world. Now, the benefit of using virtual servers is that it makes it so much easier to take away or to add resources. We can literally power down the virtual server, allocate more resources to it. Let's say allocate, instead of 8 GB of RAM, allocate 12 GB of RAM to, let's say, the web server. We can, let's say, add 4 more cores of CPU to the email server, and then we're done. It's literally as simple as that. We literally power down these virtual appliances. Now, they're called virtual because the web server doesn't actually exist as a separate physical device. It's a server running on this physical appliance. So in reality, the PCs around our network, the laptops, the computers, the mobile phones, they will all be communicating with this one physical appliance, okay? So all traffic is going to be routed, or traffic is going to go to the one physical appliance. However, the traffic is then going to be divided between these virtual appliances depending on what the computers and what the laptops were trying to access in the first place. Like I said, we use it for scalability because we can add or take away resources very easily, literally within a few minutes. Now, let's go a bit more into server, so break it down a bit more. So, like I said before, it's important to remember that a server is just a role that a computer plays. You could make your old rubbish laptop, your old rubbish computer into a server. Now, in an enterprise environment, that probably is not going to scale well. However, it's just important to know that a server is just a role that any computer can play. Now, enterprises, like I said before, will use powerful computer systems that are created to be dedicated servers. They are designed to handle a large workload, and usually this is a very important point to remember. Usually servers are going to be up 24/7. This is why you would use a specialized hardware device which was created to be a server, because these devices are going to be up 24/7. They have to have the fans to cool them off. They have to be durable to last 24/7, to be up 4 or 5. Remember, these servers, they're up constantly 5, 6, 7, 8, 9, 10 years. Nothing can go wrong with them. They have to be reliable, and they have to be strong enough to be able to handle whatever thrown at them. So they have to be strong enough to be able to handle all of the connections they receive, and also have to be durable enough to withstand running 24/7 5 years in a row. And to be fair, that's all there is really to it. So servers, like I said before, is just a computer which offers a service to another computer. Could be an email server. Where, have you ever wondered how you're able to go into Outlook, go into Gmail, and access your emails from anywhere? That's because when you go into the web application, so when you actually go browse to Outlook or your Gmail, you're retrieving all your emails from a web server. That's why we have email server, not a web server. That's why we have an email server. File server, we can store our files centrally in a centralized location, which means if our computer system dies, we can then access those files, and we can also access our files from any computer that we log into. And like I said before, we normally, especially nowadays, so as an example, the place that I work, I don't think we've actually got any physical servers. All of our servers are going to be virtualized. So it's going to be servers running on VMware. Like I said, is that we would install VMware on a physical appliance which has loads and loads and loads of hardware resources, loads of RAM, loads of CPU, etc. Loads of memory, you name it. And we're going to create these virtual servers, which are going to be essentially individual servers which reside on the physical appliance, which can be running any operating system, so Windows Server, a Linux operating system, Red Hat, etc. And we are going to assign resources to these virtual servers. Now, the benefit of using virtualized servers is very easy to then add and take our resources as we want. Like I said before, servers are really that easy. So if you like this video and you want to see more like it, please subscribe to my YouTube channel, and please share this video or share this content with anybody you know, because like I said, we want to get free high quality IT training to the masses. Thank you very much.